So today we've got a Maxcom 7E. This customer's also sent in a Fidelity 1000. So he says it sounds funny. Sent in a power lead, and we're connecting it to the accessory aerial socket with our Motorola adapter into our PL259 plug. The high-low power switch on these is quite weak, so take it easy. Right, do you know what? Is it a 12 volt set or is it 13.8 volts? I can't remember. I'm going to have a look at the instruction book. Right, I've printed off a copy of the instruction book, which, if you've ever seen a genuine copy, is about a quarter of the size of this, so I can at least read it. What does it say? 13.2 volts. So that means we're safe to work it at 13.8, but we're going to run it at 13.2 as it says. And it's a good instruction book. You get the circuit, you get the layout, you get the block diagram, and you get the instructions for alignment. So it's 2/3 of the way of being a proper service manual. Right, so let's see how it's working. So we'll switch the power supply to 13.8 and then adjust it, because we have these in presets, to 13.2. It doesn't say on the back. And it says 12 volts on the connector. That's why I wanted to just verify. Right, here goes. Power on. Whoa, it's in transmit. It thinks it's half in transmit. Right, we won't go any further, but we'll open it up. Let's hope it isn't full of water. Because the accessories which came with these included the carrying case and battery pack, and you can use it as a kind of walkie-talkie, a rather cumbersome one, but you can, and it does mean that some of these were used outdoors, and then the inevitable happens and it gets wet. Piece of string it's going to have to be. Okay. Oh, 100 yards there, 100 yards what? There we are. So I think we're going to have to take the board out, so we're going to have to disconnect it. And we have to unsolder the loading coil. Yeah, the switch has had to be glued on this, which is pretty normal. The printed circuit board there is just so weak. I wonder if we can actually unscrew that. I think it's the glue's round there. I'll see what we can do. I don't want to break that again. Do you know, I've been waiting for the soldering iron to warm up and it's not even on. I'll just power this up again and just see if the fault is still there with the lid off. I expect it is. I mean, that has got to come out. I'm sure it's going to break. Well, so far so good. So the idea is to remove that switch. You can see how thin the board is. No, it hasn't. No, it hasn't previously broken. It's just the amount of glue on that screw. Got to pull it up vertically. There we go. I'm going to have to take the screen plate off because I'm sure that's what's going to have happened. Right, let's have a visual inspection. I can't see any moisture ingress. Well, I'm sure it's going to be a dry joint. I don't recall ever having had dry joints on these, but it's always the first time, especially now they're 42 years old. Right, let's power it back up. Let's just put the aerial back in. I don't like running things which could be halfway between transmit and receive. But no output, have we, without the no, that feeds the other output. So it's the right way around. Let's see what happens. Nine. Let's take it back to about 10 channels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to put the frequency counter up on the inset picture because we can then see together what frequency it's actually on. Because once you've taken the channel selector knob off, it's 7, 8, that's channel 19. So 7, 9, 27, 7, 9, 0, 8, 5. So we're on channel 20. Let's put the signal generator on that. It started off frequencies. You saw 27, 7, 9, 0, 8, 5. I'll put this on the proper frequency whilst I do some fault finding. a whacking great big signal and it's stuck between transmit and receive, isn't it? So let's go to the main meter. It's doing 50 milliwatts or something. Are we switching in the wrong position? Yeah, it's doing 3 watts on there. Well, that's a bit of a corker, isn't it? It thinks it's partly in transmit. Right, switch it on. So if we look at the circuit diagram, so we've got a TX lamp is there. So we need to... I'm going to do some fault finding and then I'll tell you what my conclusion was if we come to one. Well, about 90 minutes later, no profit in this one. We've got receive. So I took out transistor 9, which clearly is the transmit receive switching transistor. Well, it tells us it is anyway, but I discovered that later. So I had to go much further down into this, take all this bit off. You've got a big capacitor there and transistor 9 is just there. So on the diagram, there's transistor 9. On the circuit, there's transistor 9. So I've replaced that off a scrap chassis. Now this customer has previously sent in a scrap one of these, so he hasn't to pay for any parts. But I haven't got the heart to charge him what it's cost it really, so we'll just charge him for 2 hours when it's even actually finished. So what I'm going to do is we'll put it back together. Receives excellent. Transmit is just short of 3 watts. So put it all back together and come back to it and we'll do a tune-up. Okay, so apart from the high-low power switch, we're back. Oh, helps if we switch on. Right, see where we are. Let's put this thing on frequency first before we go any further. The gear's been on for plenty of time. Put the frequency counter up. It was 086 when we started off. It may well have gone somewhere close. 2779086. No, the gear had been on long enough. So we'll put that on the clipboard. 79086. Q9 replaced. Hopefully it'll go. Tell you what, we'll switch it on low power so we're not making the transmitter hot. Before I just willy-nilly... Yeah, it looks like the right one. Just have it slightly over. So because it dropped with age, 2779127. Let's go to the main meter. Turn that volume down. Main meter. And we're obviously on channel 20. And it's doing 2.9 watts. Now I've got to find the other channels, haven't we? This is fun. That's counted 20 clicks, so we should be somewhere near. I'm spot on. Channel 40, 2.7 watts. And channel 40, that was channel 40, channel 1 hopefully. Yep. I'm going to say 3 watts. It was 2.95 and a bit. Go back to channel 20. It's that one. Low power. And it's 120 milliwatts. I don't think it's adjustable. And on full power, we're drawing 973 milliamps. Deviation, for what it's worth on this test set, needs tuning in. We're on CPT last. Wallow. It says 1.4, which it could be. You know, these often sell for less than what the service cost of this is going to be, but what's good about this, it's not had any ingress of moisture. I've only got to show you the screen plate of the one we use as a scrapper, and that's not bad, but it's much more tarnished than the one which this one is. And this has been in somebody's cupboard nicely. I'll just put 1.4 in brackets. Is the other test set on? Yeah, the other test, I'll tell you what, we'll do the deviation right now. Can't remember which one it is though. RV2, it's supposed to be 2.2 it says, which is right. RV2. Is the one up there. So the one where PTT, there's a preset there, it's not that one. Yeah, it's right up there. You can see I'm on a bit of an angle to get in. Anyway, we'll put it onto the test set. Change glasses. Because I've got to kind of waltz the whole thing over. Wow, it's 2 exactly, so we'll just pop that up. Wow, there we go. So my Marconi test set is lying today, which it usually does. So there's only the deviation function. seeing as we've got 5 test benches here and the other one's directly behind me, it's no problem. See what this Marconi test set now says. Well, it says 1.8 something. So I know it's right. So it was 2. It's now 2.2 to 2.5 peak. Right, let's go through the transmitter. It's going to be that and that and that and that, isn't it? Let's see what it says in the book. So it actually tells you how to do the phase lock loop. Well, we don't need to do that. You know, that is absolutely brilliant. So it goes on here about connecting an oscilloscope to the base of transistor 7 and adjusting for the maximum amplitude. The point is, it's already working. If it was a case of setting it up from a factory situation, yeah, that might well be quick. But you know what? The walkie-talkie trick 4 inches away is a very quick way of setting it up. So ensuring that the power supply is at 13.2 volts, connect a watt meter to the antenna connector and we're checking L2 and L5. L2 and L5. Those two. So that is done. It's not just done with the analyzer. L2 and L5, and then touch up L1. T2. And T3. Right. So I want us to peak these first. Trust me to be in the wrong mode. We'll go into the 30 watt scale, so we're at 3.2 watts. It's more than most new radios do. We're at 4 watts, you see, so I'll just run through the earlier stages just to make sure it's central. Just need to drop the power a fraction. There we go. So we've got 4 watts at channel. As long as it's in within 0.1, we're there, aren't we? So let's try and count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somewhere around there. Yeah, I've counted right. So we're doing 3.9 watts there. Let's try channel 1. We're doing 4.05. That's fine. Count them back. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I've missed it somewhere down the line. done a few too many clicks. It's probably that one which has got the tone on it. Right, what's the other preset then? Is it low power? You're not telling me it's squelch. Yes, squelch is RV1. So back to the clipboard. Let's have a look at our current consumption. It's now 965 milliwatts. We've come down and gone up a watt. Don't we like it when that happens? And low power, is it better or worse? So we've got 120 milliwatts before. It's now 120 milliwatts. Okay. So no meter, no meter, no meter lamp. They work, none of that. That works, and that works. So we've just got our receive to do. Now, of course, we haven't got an extension speaker, so we've got to start with the old crocodile clip trick. Should just need to connect the inner. Yep. So just clipped it on the speaker. A little bit more volume on. It doesn't sound very good, but let's see where we are on frequency. 27.79125. It's got 100 microvolts. I'm not. No, I better do the. I better read it first. Otherwise, we don't know whether we've improved it or fixed it worse. So, a bit more volume. Let's go over to the synod meter. They're quite a simple receivers. They're not as refined as some. Oh dear, it's miles out. I wonder if it's been twiddled. So we've got at the moment 2.3 for 12 dB. We've got 1.9 for 10, and it can't do that. Squelch. Is 3 millivolts on tight, which is too coarse. Go to see where the sensitivity is. We're at parts at 0.3 of a microvolt. Drop the squelch on the radio, that's the volume, and put it back on, and it's 1.8. which isn't good enough. So something's well out. So we'll start with a 100 microvolt signal on it. We've got rather a distorted looking receive. It's probably some time I've been fiddled with to try and like it's gone out of alignment to stop it receiving at all, which it won't have done. The instructions in here are like it's AM. Somebody hasn't sussed that right. Let's see where the detector is. It's T8. So you'd expect it to be somewhere. It's there. Drop the volume rather than adjust the oscilloscope. So that was miles out. I'm going to look at that IF one next. Let's get a lower signal. Go to the cyanide meter. I haven't fixed it so that it's deafer, having done the detector. Let's put it to 12. It's now about 1.3 microvolts, so it is better. And we'll just adjust that one. No, that wasn't out. Okay, we'll drop the signal. It's about there, 6 dB. And we'll go through the front end. There's only 2. Drop the signal again. And then we'll recheck. Recheck. So it's 0.95 for 10 dB. For 10. .86, and if it'll do 20, yeah, it will now. It's 1.7. Okay, we'll do the squelch. Now that might have come right. Back to the attenuator. Squelch to full. 3, 10, 30, 100. I want it to come in at 100. Well, it never comes in at 100. Ah, that's it. Just see what maximum sensitivity is like. It's probably where we want it. So maximum squelch like that is 260 microvolts. I can live with that. And minimum now, let's turn this to standby. Park it at 0.3, turn the squelch down, set the squelch, signal generator back on. 0.9. Good. Now, it's not the most sensitive set in the world, but then it isn't like a Cobra 29, as deaf as that. See what it's supposed to do. Less than 1 microvolt. It is well less than 1 microvolt. Right, turn that off. We'll screw this back in. I'll tell you what somebody ought to do, and that is to copy this little board and make replacements on fiberglass. And that would cure the problem. Right, we're all back together. Because I'm going to put some hot glue on that printed circuit board to protect it from that sub board, because they're so weak. I've just popped a couple of screws in for now, and I'll just do the hot glue gun behind the scenes. But you haven't got that problem with the Midland because it doesn't have the high-low power, but then the high-low power is really useful. So we're on 19. The knobs never line up on these. Trying to find the channels is another thing, and there goes the phone. Okay, that was another firm offering pneumatic motors for church organs. So I said, well, send me an email. We're not call from them at the moment, but we can keep it on file. So where were we? Yeah, we were about to whip through the channels and see what good buddies we're on, or bad buddies. 19er Roger. Roger. Well, so it's about 11:15 on a Saturday morning, and there's nobody on, which is great. So there we are. So Maxcom 7E, with probably the most difficult fault I've ever had on a Maxcom 7E, because it took some thinking about, and you wouldn't normally take these kind of sets to that kind of level. But there we are. I'm pleased. It suits me down to the ground. It's another one saved. Thanks for watching.